Hope you're enjoying the reading for the first week. For week 2 of ISDA 609, as you know, we will host live meetings this week. If you please try to make an effort to participate and ask me questions if you have any. If you cannot, make sure you would review the videos that we will put on the internet, put in Blackboard system later on. Okay, for week 2, we're going through some fundamental concepts, the modeling process, proportionality, and geometric similarity. So mainly we will be talking about modeling using proportionality and modeling using geometric similarity. And there is some very good example of automobile gasoline mileage and also body weight and height, strength, and agility. Um, let's go over those. This is the classic example between real-world systems and the mathematical world, and these are two different angles to look at how we may think about relationship between math models and the real world. So, as you can see here, for real-world problems, we have two branches. One possibility is to have a mathematical model to represent the problem. The other one is a possibility of replication of the behavior, either through experiment or through simulation. So in very complex system, if we cannot mathematically represent the problem, we could use simulation to help. Here are some different examples of the model types. We could have a lot of real-world observation. We try to do a little bit experiments or simulation to narrow down to sample from the observation and construct mathematical models and select models. Or it could be on the other hand, we don't really have a lot of observation, and then we have to try to augment our data set using experiments or simulation, and then build the mathematical models on top of the observations we simulated. Here are the steps for construction of models. As you can see, it's an iterative process. Essentially meaning that we have to make some assumptions to solve the model, verify the model, implement the model, and then maintain the model. But in between, we could go back to further refine the assumptions or improve the problem and implement the model. Again, I try to be very flexible in terms of the model refinement. Proportionality, y equals to kx is a linear relationship here, as you can see. Y equals k1 x squared, and then it could be nonlinear, quadratic in this case. And y could be proportional to ln x. Y could also be proportional to e powered by x. So here are some very classic examples of proportionality. I believe you have already learned these concepts in high school physics. We are going to learn how to fit a linear model in chapter 3. There's another way to look at the problem. It's modeling using geometric similarity. So here it says, two objects are said to be geometrically similar if there is a one-to-one correspondence between points of the objects, such that the ratio of distances between the corresponding points is constant for all possible pairs of points. And chapter 2.5, section 2.5 and 2.4 have very good cases for these topics. These are the homework for chapter 2. Make sure that you would submit the homework by the end of Sunday night. Thank you.